Okay, check this out. We're going to solve a 3-variable system today. Now, I'm going to tell you right now, we're probably only going to do one example with me doing it step by step. Then I'll have one example for you to try on your own to see if you did things correctly. And that's probably going to be about it, because the first example is going to take us quite a few minutes to do one problem, because I'm going to explain every step. And it does require a lot of work. It's not very uncommon for this to take a quarter to a half sheet of paper to do one problem. So, pay attention. Let's go. First thing you want to do is you want to look at all 3 equations and look at x, y, and z, and you want to find what looks like the easiest variable to work with, meaning you don't have any coefficients in front of it. So I see a positive x and a negative z. It doesn't matter. Either one of those will work fine. So I'm just going to go with x for fun. So I'm saying that x is going to be the easiest variable for me to work with. So what we're going to do is we're going to write that equation twice. X plus 4y plus 2z is equal to 3, and you write it down twice. And that leaves us with 2 other equations. So what we're going to do is we're going to take the top equation and write it with our easy to work with equation, we'll call it. So we have 3x plus 2y minus z is equal to 10. And then we're going to take the bottom one, the other one we didn't say is the easiest, and we're going to write it with the other one. So we're going to have 2x plus 3y minus 5z is equal to 23. So basically what we just did is we just took one big stack and split it into 2 littler stacks. So this is what happens. We are going to multiply this top equation here by a negative 3, because remember, x we chose is the easy variable to work with, so we're actually going to eliminate him in this problem right here. So this is going to become a negative 3x minus 12y minus 6z is equal to a negative 9. And what's going to happen is our x's go away like we planned, and then 2 minus 12 is a negative 10y, negative z and minus 6z is negative 7z, and 10 minus 9 is 1. So we eliminated x from this side. We're going to go over here and we're going to eliminate the exact same variable, the one we say is easy to work with. So we're going to multiply it by a negative 2. That'll give us a negative 2x minus 8y minus 4z is equal to a negative 6. And what that's going to do is that's going to eliminate our x here, leaving us with a negative 5y minus 9z is equal to 17. So we still have some work to do, but this is something that you also already know how to do. We are just going to create a new system with those 2 equations that are left. So we're just going to write negative 5y minus 9z is equal to 17, and negative 10y minus 7z is equal to 1. And we have another 2-variable system, something that you're already very familiar with working with. So we're going to multiply the top one by a negative 2, giving us 10y plus 18z is equal to a negative 34. That's going to make our y's go away. We'll have 11z is equal to a negative 33. So then we have z is equal to a negative 3. So far it took all of this just to find the first variable. But once you have the first variable, you are on your way working backwards. And when I mean working backwards, you're just going to substitute into previous equations until you find the other variables. Okay? So this is what we're going to do. We are going to start by taking our z, which is negative 3, and we're going to substitute it into one of these 2 equations, and we're going to find y. Alright, so let's just start. Let's go pick the top one, negative 5y minus 9 times a negative 3, which is equal to 17. Negative 5y plus 27 is equal to 17. Negative 5y is equal to a negative 10, so y equals 2. So now we have 2 variables. We have z is negative 3, and we have y is 2. So now you need to go all the way back to one of your original equations, and we have to solve for x. Well, why not go back to that easy one so we could just substitute it in and find what we need? So we're just going to go all the way back to our original. X plus 4 times, we know y is 2. Plus 2z, we know is a negative 3. And that's equal to 3. So then we're just going to solve for x. We have x plus 8 minus 6 equals 3. That's x plus 2 equals 3, so x equals 1. And you are just about done. Last thing, remember you must write systems as an ordered pair, or in this case, now that we have 3 variables, it's an ordered triple. Our final answer is 1, 2, negative 3, written as an ordered triple, and I highly advise that once you are finished, you take your calculator and you go back and you substitute 1 in for x, 2 in for y, and negative 3 in for z, and you make sure that all 3 of these equations work. If they don't, if one of them breaks the rule somehow, then you have a variable that is incorrect, and it means all that work you just did was for an incorrect answer, and you should probably take a little bit of time to go back and check just to make sure you are correct. Okay? So remember, step 1 is to find the easiest variable to work with and write it twice, and then write the other 2 equations with it. Step 2, you eliminate the first or easiest variable in each set to create a new set of systems, and then you solve the system, and then just keep on working backwards as you substitute values back in until you get all the way back to one of the originals and write your answer as an ordered triple. Okay? So there you go. 7 minutes for one problem. Here you go. What I will do is I will allow you to copy this guy down, and then I recommend that you pause, and once you press play, the answer will magically appear, and we'll see if you have the correct answer. If you struggle with it, you know that you get to ask questions in class, so make sure you ask about it if you have any trouble. So pause it, and in a few seconds I'm just going to write down your final answer, and you can check it. Have a good one. Is that the answer you got? The first thing you should have done is looked. I found that the easiest variable to work with was the negative y in the second equation. Then you should end up with 2 equations of 7x plus 10z equals 19. Negative x minus 4z is equal to negative 13. The first variable you should have found would have been either x or z. So z I got 4, and then I worked to x and got negative 3, and then I got y equals 2. So there you go. That's the answer that you should have had for that one. Okay? Now there's a couple more examples, and we'll just talk about them real quick. The first one, number 3, this is when you don't have a lot of other variables, but you still have 3. So we only have 2 here. One recommendation that I would have for you when you do this problem is to rewrite it as 2x minus 3y plus 0z is equal to 5. And then 0x plus 4y plus 2z is equal to a negative 6. And then you have your 5x plus 0y plus 7z is equal to a negative 15. By doing that, you will see that all you really need to do is eliminate one variable somewhere, and then you've already got the other one taken care of. So for example, we can write this part down at the bottom here, 4x plus 7z is equal to a negative 15. And we're going to work with that. So then all you have to do is you have to take the top 2 and you have to eliminate the y, because you can't eliminate the x because this is 0, and you can't eliminate z because this guy's 0. So the only one you can eliminate would be the y. So what I'm going to do is I'm just going to make some room here by erasing that piece. And what we're going to do is we're just going to eliminate this now. So we can multiply this top by 4, and we can multiply the bottom by, a regular 3, and that's going to give us 8x minus 12y, and this one down at the bottom is going to give us 12y plus 6z. And obviously we have our equals 20 and equals negative 18, and what you can see right away is that these guys cancel, and you're left with 8x plus 6z is equal to 2. And then from there, you just need to solve the system and take it all the way down until you get all 3 variables. Okay, so why don't you pause the video and try to do that on your own right now. So, did you get it? After you eliminated your y, you have 2 equations, 8x plus 6z equals 2 and 5x plus 7z equals negative 15. So you just had to multiply the top and bottom by negative 5 and 8, or you could have switched it, did 5 and negative 8, doesn't matter. You could have also used negative 7 and 6 to get rid of the z's first. It doesn't matter which order. So then you solve, you get z equals negative 5. Come backwards, you get x equals 4. Go back and you get y equals 1, and you're done. Final answer is 4, 1, negative 5. We have time for one more example, which is fine because question 5 is a word problem, and the next video is going to be pretty much all word problems. So what's going to happen here? Question number 4, we're going to skip all the way to some good stuff. So obviously we have a positive z here. This is going to be the easiest one to work with. So you're going to stack these together with the other two like we start anything, but something funny is going to happen. Once you eliminate the first stack, you're going to end up with x plus y is equal to 3. And you're going to eliminate the second stack, and you're going to get 3x plus 3y is equal to 9. Okay, now this is after all of that first couple of minutes worth of work happens. So what happens here? You're going to multiply this guy by a negative 3, and you're going to end up with negative 3x minus 3y is equal to a negative 3. And everything, equals to negative 9. And everything's going to go away, and you're going to get that, oh, hooray, there's infinite solutions. But there's not the same line. There's 3 lines now. So what does this mean? Well, this means that there's actually 3 lines in 3 space, which are actually kind of like planes that are the exact same. So what are we going to do? Well, just for fun, we're going to take it a step beyond, and we're going to find out the rule for this infinite solution. To do that, we have x. So our rule is going to be x comma something. What's y going to be? Well, y is equal to negative x plus 3 because all I have to do is solve for y here. So our rule for y is the opposite of x plus 3. And then we have to go back and find z. So you just take one of your original equations, and we're going to have our negative 2x plus 4, but y we know is a negative x plus 3. And then we have our plus z equals 1. Distribute, so negative 2x minus 4x plus 12 plus z is equal to 1. And then you're going to solve for z, and you're going to get z is equal to 6x minus 11, and that's your rule for z. So basically what we just did is we found out that there are infinite solutions here, but they must follow a rule. So whatever x is, the opposite of x plus 3 is what your y value is going to be, and 6 times x minus 11 is what your z value is going to be. So if I told you x was 5, you'd be able to figure out what y and z have to be to make this infinite solutions. Okay? So that's it. I understand we skipped all the pre-game work for this, but you know, we did the first couple, and you should be pretty familiar with that. And the last one's a word problem, and like I just said, the next video is going to be pretty much all word problems, so we're going to skip that one for now. We can talk about it in class. If you want to see it and try it on your own, here you go. Have a good one, and we will see you soon.